Hello guys, welcome back to Root and Route. This is Diljit here, and today we are continuing with our ransomware simulator project. And in my previous video we did develop a ransomware simulator using the hybrid approach using RSA and AES-GCM, and we did create the key pairs, and then we did simulate the real ransomware, how ransomwares use pinned public keys to encrypt the AES-GCM key generated randomly at runtime. Then now we have to do this part, the decryption part of that. We have to decrypt the AES private key, and then we have to decrypt the actual encrypted file data. So let's move to our project. Before moving to our project, I would like to introduce one of the main concepts in Rust. It's called Workspace. Basically, it is used in projects with multiple packages that are interconnected. Means in real time, normally when you develop a big project that has multiple parts, and one of the parts, if you decide to make it as a shared library, then you can make use of this workspace. Here, why I'm going to use the workspace is because it's connected, even though it's not interdependent, but it is connected in a way that we created. If first we created the keygen, then we created the ransomware simulator, actual simulator. Now we have to develop the decryptor. So instead of keeping in 3 different places, I would like to keep everything under one workspace, so it will be easier for us to refer the code. So let's go and do that first. And we already have 2 projects here, Genkeys and ransom underscore sim. Those were the projects that we did for the ransomware simulator. Now, before doing the decryptor, because why I'm doing this one, just to save time, since we are going to make use of this the reverse of the same technique that is we use for the ransomware simulation to decrypt the file. Before decrypting, we have to decrypt the AES-GCM key. So for creating a workspace, what you have to do is you have to create a folder first. Just make it as ransom simulator. Maybe confusing, but we will rename the other one. So I'm going to open my editor here. So inside the folder, what you can do is you can create a file, cargo.toml, and here you can mention it's as a workspace, and under the workspace you have to mention the members of the projects. First I will say Genkeys as my first project, then simulator as my second project, then the third one is the decryptor. So these are going to be the 3 projects that we are going to make use of inside the workspace. Let us go to the terminal. Now the next thing, we haven't added any source code or anything here. How we can add now we need to create the actual members into this one. For that we have to use cargo new and just say Genkeys. See, this will create a folder with all the source and separate toml file here. It is an independent project here in this one. Just like this, we have to create the other projects. Now see, this cargo.toml is exclusive for this Genkeys. and this one is a workspace terminal file. So the next one we have to create is a simulator. And the other one is Decrypter. Now we have our 3 projects here, so let me copy the code from the other projects that we already did here. CD Jenkins. Open. Just copy this code, and inside our Jenkins source folder, if you are seeing this video first time, I mean like you're directly seeing this one as a first video of this series, it may be confusing for you because we already did this on the previous video and we explained what we were doing. And I have to copy this terminal file dependency, and it should go here. So now what you have to do is you can either build or run the project. I'm just using the build. I'm just saying I have to build my Jenkins project package, and it is saying something failed to pass. Or something is missing. Let me check here. Is it Jenkins? Let me check this. We added the members, and yeah, what did we wrong? We have these things here in place. Maybe some. Let me check it. Cargo.terminal workspace. Is there any spelling mistakes there? Workspace. And members. Workspace members. Where is that presentation? Workspace equal to members is this one. Okay, better check there. Failed to pass the manifest. Cargo.terminal. This cargo.terminal. Oh no, it's spelling mistake. Yeah, this could happen at any time. Yeah, now it is building, and if you can see, it automatically generated one target folder here under the ransom simulation folder, and now our key will be here. I mean the app will be here. So what we can do is either you can now you can move to the folder and run it, or just directly run instead of build, so it will generate the keys for you. Now we have to copy the other code from our other project, the simulator project. So the simulator was ransom sim, and again I'm saying, if it's confusing for you, maybe you are watching this as the first video. If you did watch the previous videos, it would have been easier for you to understand what we are doing now. So here the simulator source code main, I'm just utilizing it here, and we have to take the same toml file from there, copy this, oh no, did we copy? And this is all the dependencies that we were using on the simulator. So now try to run, now try to build it first. Let me build it. Oh, what is the, oh sorry, name of simulator. Oh yeah, this could be because, yeah, if you go to the simulator, what was the error? Couldn't read the simulator source public PM, because I already explained this on the previous video why this error is happening here. And here is a source code, because we don't have the file under this folder. This include str macro needs the file on the path where we are specify here, and for that what you have to do is you have to go to cd target debug, and now gen keys, and if you check where did it create the keys? Interesting. It should generate the keys where it is running. Did it create? Oh yeah, it is here. I don't know why I'm not seeing it here. Maybe I need a refresh, or you guys are seeing it here. I think it's not there. See, it's created here, the private and public key. So we have to copy the public key to the I think better copy the endless path. That will be and why it is not working? Okay, cp public key to then resource target ransom simulator source. Now we have our public key in this folder. So now this should build our simulator project. I think we have to move back to the main folder, cargo build project, package name is simulator. Now it should build. Yeah, now it doesn't have any error. So now the target folder might have one more project. It's, I think, why it's not refreshing, I'm not sure. cd now we have simulator and Jenkins. Now if you check the simulator code here, we need to mention the path of the file that needs to be encrypted, and that's the only parameter that it needs. So for testing that, I'm here in the same folder, so I'm creating I think I can create a file here itself. Now I think it's updating. Same, where is the folder? Here. I'm creating a file called encrypt test encryptme.txt. This is for testing the simulator. And now I'm going to run the simulator and encrypt me. Sometimes if you have, so practically it should, as per the implementation, should have deleted this encrypt.me file, and it must create a file like this. Up to this we have done on our simulator on last video. Now we have to develop our actual decrypter. So when we are doing the decrypting, we have to be careful when you're reading file. You should know, because since as an attacker or a tester or a red teamer, you know how you created this file, the package. So we did write the Nonce first, the first 12 bytes. Then we did write the encrypted AES key, that is 256 bytes, that is 2048 bits. That's why because we were dealing with the bytes here, so the encrypted AES key has 256 bytes before, like at the time when you are writing to this one, since we did use the 2048 key length. Then we did write the encrypted data. So when we are going to decrypt it, what you have to do is we have to do the reverse order. Here we use the public key to encrypt the AES key. So when you're going to do the decryption, you have to use the reverse order, before decrypting we need the encrypted key. So we have to read from the file exactly like the extract it in a way exactly like the way that we have written. So how to do that? For that, before doing that, we need all the dependencies that we use here in this one for the decryptor, because it's same process that we are going to do. Instead of the encryption, we are going to do the decryption. That's only difference. So come to the source code. Even the source code, I think we can use the use part. We can make use of this one, and there is no need to pin the private key here, since it doesn't, I mean, even if you want, you can do that, but it's better to read it from the file directly. So here we are going to use the same thing here, and I think for even for the main return type, these things we already explained. So it's going to be, we are throwing the error to the box, and it's going to be the standard error type. And now this will resolve it. Let me snow. Oh, it's already disabled. Okay. Yep. I just wanted to disable the AI part of this one. Snooze. Yeah, snooze. Yeah. Because that is very annoying sometimes. So let us do just take the arguments from the command line. So it should be string, and it should be string, and we have to take it from using the env and edges that we already did. That's why I'm just going faster on this one. And let you can say that the encrypted file path equal to so now we have, yeah, this is a mistake actually. This should be called now we have the encrypted file path. The next thing that we need is the private key. Let our private key in PEM format that we already said. Just read the key. So I'm going to give the path here, direct path, because since we have, as an attacker, I know where it is, so I'm going to keep it in my same folder. And I think the key is already here, so it doesn't make an issue. Where is the key? Yeah, it is here. So we have the PM. Now we have to convert this to the actual key. So for there we use the okay, here we need to have some changes. Instead of these packages, we just need the private key here, and in PKCS version 8 we need decode private key, and yeah, rest are OEAP and SHA are same. Why we need that is we need to generate the actual key from the PEM format. So from here we are going to do the this method code from PKCS 8 PEM and just pass the reference to our private key PEM format, and always try to propagate the error using the question mark, and otherwise everything is going to show us an error. What error it is showing now? It's PEM format I did read, and we have the private key from PKCS PEM. I don't know what error it is showing now. Found a vector and oh, sorry. We have to do the read to string. because here it's expecting a string reference. It's not the vector that we need. So now we have the actual private key with us. Now let us try to extract the file contents from the actual file. So what we have the encrypted file path. So did we read the file? Oh no, we didn't read the file. Okay, we have to read the file content. Let encrypted file content equal fs read, and where's the encrypted file path, and propagate the error. So for the none bytes, we have to extract the encrypted file content. So as I explained in the beginning, we should know how we pack the file. The first 12 bytes were the nonce bytes, and let the actual encrypted key, AES key. So this one was starting from where to where. You have to extract it from 12 to the next 256 bytes. So it is 268, right? Yeah. So now first we extracted the nonce bytes, then we extracted the next 256 bytes, because that's our encrypted AES key. So and the remaining portion is our ciphertext. So we are saying that we have to encrypt encrypted file content from 268 to the end of the vector. It is our actual ciphertext. So now we have the encrypted content with us. We have to decrypt it. So first we have to decrypt the AES key. So for that we have to use the private keys decrypt method. So there we use the public keys encrypt method to encrypt this AES key. So here you have to use the reverse, and as you know, we use the OAP padding for this one. So you have to mention the same thing here, and it was SHA-256, and this is a function, and then we have to say which data we need to decrypt. So here we need the AES key. Where is the AES key underscore key? Oh, sorry. Yeah, it should be the encrypted AES key. Yeah, it's correct. It should be the encrypted AES key. Then we extract the result to the AES key. Now we have the AES key with us. Now we need to make the AES cipher. For that we have to use the same AES-GCM 256 here, and generate the key, and we did all these things in the previous video, and we explained it almost 3 videos. So that's why I'm just going faster on this one. from slice method, and we had to pass the reference of AES key. And yeah, now we have the cipher with us. Now we have to create our nonce from the nonce bytes. So I'm going to use the method nonce from slice, and we already have the nonce bytes. So now here the cipher, the nonce. Now let's decrypt the data. Decrypted data equal to is the cipher dot decrypt, and pass the nonce, then the ciphertext. Then you have to use the map error since map error, and these things again I explained why we are using map error here, and how it was to string to convert the type, then propagate. Now we have the decrypted data with us. So the next thing is just write the decrypted data. Just say decrypted.txt and txt, and what was the data? Decrypted data. And what is this one? There is no need of this. Yeah. So the process is almost a reverse of the no, what was the error here? Ciphertext is showing error. Decrypt, or not ciphertext, it's cipher underscore text. It is almost the reverse of the writing. When we pack when the ransomware simulator was running, and after encryption we packed the file in a way that the first 12 bytes were the nonce. Then after that we did write the actual encrypted AES key into that. Then we did write the encrypted file content, the same file. So in normal, in a real-time scenario, it is not safer to keep only on one place. So if you are planning to simulate this, you have to keep this the same content. Same AES key, the encrypted AES key somewhere else, like in a DB or somewhere, instead of only keeping into one place. Of course, it's okay to keep it in here, the file, but if in case something happened, if you want to, because we normally do the simulated the control simulations, not the actual attack, so you should be very careful on that. So let us try to run it. Then we are going to do cargo build package decryptor. Hopefully, yeah, it didn't make any issue. cd target debug. Oops. ls here, and yeah, the decryptor is here. On the decryptor, we are going to give the encrypted file, encrypted.rans. If our operations were correct or the readings were correct, it should make the decrypted content for us. So no error was there. Let us check. See, the decrypted.txt is here, but just confirm it was the correct one or not. See, we got the exact thing that we did right. This is for testing the simulator, and everything is working perfectly now. Now we have a full control ransomware simulation. We did generate the public key, the key pairs, then we did the actual simulation. Now we have the decryptor for that. So, and I just made it under one workspace just to make it easier. Otherwise, it's very difficult to explain everything again. And if you have any doubt on how we did the encryption and the key generation, please refer to my previous videos. And if you have doubt on any doubt on the AES GCM part, we did 2 detailed videos on that. One was for actually generating an decryption tool. The second video was for generating how to encrypt and decrypt shell codes using AES, GCM and XORing. So everything is there. If you have any doubt on, please refer the previous videos. Everything will be clear for you. And that's all for this video. I think it is comparatively, this is one of the smallest videos I have done in this channel till now. I think this I can say I don't have anything else to say. Just wanted to show how to how to develop the simulator for the same ransomware, decryptor for the simulator that we did previously. That's all for this video. See you soon with another one. Till then, it's a bye from Root and Route. And if you like the content, or if you feel this is something different from other channels, consider subscribe and share and like. That's all. See you soon.